Hi, greetings from beautiful upstate New York. This is Dave Duggal, founder and CEO of EnterpriseWeb, and I'm fresh back from the TM Forum's Innovate Americas event, where we presented realizing an ODA-compliant service inventory over Snowflake aggregated data and then exposing those related open APIs via the Model Context Protocol to agents. I was really pleased to be up on stage with my friend Sreedhar Rao, Global Telecom CTO of Snowflake. For those of you who didn't attend the event in person, we're going to recreate that presentation and the demo for you today to make that public. And first, before we proceed, I just wanted to thank Nick Willits at the TM Forum, as well as Andy Tiller and Katrine Paranen, who helped with our session. So let's move ahead. The thesis of our session was that in order for telecoms to unleash the value of network data, enable intent-based orchestration and autonomous networking, they need a unified and harmonized network model. A standards-based telecom ontology can provide the missing links to connect, query, simulate, and manage operations. And that's what we're going to show in this demonstration today. Importantly, by having a model of the industry standards that's deterministic, we're complementing the probabilistic nature of AI and Gen AI. So let's take a look at the solution. So what you're seeing here is a Snowflake environment running on AWS. Many of you know that Snowflake is cloud independent, so it can run on AWS, GCP, and Azure. Here we're on an AWS-based Snowflake environment. On the far left, you can see the AI data cloud, where telco warehouses would reside. And on the far right, you see the Snowflake's LLM called Cortex. In the middle is the Snowpark Container Services. That's where customers and partners can deploy apps right into Snowflake. Those are usually narrow in scope. They're data apps. They're apps running right over the data. Based on the cloud-native serverless nature of EnterpriseWeb, we can actually deploy a very rich system, a context-aware information system, right inside, running co-located over the telco data, running in a container in the Snowpark Container Services. So that's what that looks like. EnterpriseWeb is running as a cluster of pods inside Snowflake. You can see the Telecom Ontology is now local to the data warehouses. And we're able to use that ontology to do entity extraction and algorithmic mapping out of the telco's data warehouse. That results in a set of typed objects in EnterpriseWeb that are auto-filled with standards-based industry standards-based metadata, as well as wrapped in standards-based interfaces, which gives us very rich objects for querying and a declarative environment that supports natural language interaction with agents and LLMs. So the first value proposition is that we're able to enrich the Snowflake aggregated data with the telecom ontology, including the TMF and other industry standard concepts and metadata. The second value proposition is we're able to generate and maintain implementations for the set of TMF Open APIs with no code. So here you can see we're projecting out of the standards the TMF ODA Service Inventory with TMF 638 and TMF 701 for the purposes of this demo. From there, we wrap the TMF Open APIs in the Model Context Protocol to enable agent-based automation. Now we're doing this through our secure gateway, so role-based access control as well as attribute-based access control and our strong governance is all enforced for any agent interaction. You can't do anything beyond what has been permissioned for those registered agents. And that's important because governance is a challenge right now in the agentic AI space. So I mentioned we're also leveraging Cortex, their LLM, and that's what's going to allow us to talk to the network, query the network, as well as make requests to the network, such as order a new service, and you'll see that in the demo. In EnterpriseWeb's case, we're using the ontology to optimize LLM interactions. So we are low token, low latency, and energy efficient, And at the same time, we're deterministically validating all LLM inferences via the ontology. So this is sort of flipping the script with GraphRag, where GraphRag is generally tightly coupled to an LLM, and it's subordinate to the LLM. EnterpriseWeb's on Telecom Ontology is acting as a control language over one-to-many LLMs. This is an important distinction. Instead of having the LLM as the center of the solution architecture, the deterministic domain model, the Telecom Ontology, is the center of the solution architecture. And this is critical to being telco great, to be agentic, to be autonomous, and to be available and reliable, with confidence. So my colleague Bill is now going to take over and provide the demo. Just want to point out that he's going to be moving between EnterpriseWeb's graphic user interface, Snowflake, as well as LangGraph agents in the course of this presentation. Whenever he goes somewhere, he will tell you where he is, what role he's playing, and what he's looking to achieve. But what you'll see throughout the demo is that it's a seamless interaction. So enjoy the demo, and I'll pick it up on the other side. Take it away, Bill.
Hi, I'm Bill Malik, Chief System Architect with EnterpriseWeb. I'm going to methodically demo the joint solution between EnterpriseWeb and Snowflake. We start in our Model Manager UI, and the first thing you'll see here is a directory of the ontology itself. It starts with our upper ontology, which provides all the generic business concepts and system types that are going to be common across domains. Now, if I click into the upper ontology, what I can see is a very rich graph-connected model that's much easier to navigate than a complex information model such as the SID. You can literally walk these relationships and navigate the graph. If we zoom in, we can see interfaces here that are common across industries, including things such as the A2A protocol, MCP, Model Context Protocol, ACP protocol, and so on that are common across the agentic space, and which we'll use to expose the TMF Open APIs and an ODA inventory to an agent later in the demo. Now, core to our demo is our Telecom Ontology. It's a harmonized standards-based domain model that includes telecom-specific concepts and types, plus concepts and types it inherits from the upper ontology. And if we zoom in, we can see this right away. We see concepts such as A2A and MCP that we just looked at in the upper ontology. We can see that it's surrounded by a lot of domain-specific kinds of concepts like protocols, diameter, netconf, etc. We'll even see things like the GNMI standard that's used for configuring network devices. And again, this provides a kind of harmonization across all of the different standards bodies that we might want to work with, including the TM Forum. While the Telecom Ontology is a union of all of these standards, we can also see each of the major sources, including the TM Forum. By separating this way, we're able to actually manage each independently, supporting change management and even multiple versions of each standard. Let's drill into the TM Forum. We see familiar concepts such as the SID, Open APIs, the ODA inventory, and if we wanted to zoom in, we could even follow it right along the graph to see how our ODA service inventory implements a couple of open APIs right through to the open API set, and even following it through to interfaces, implementing protocols such as A2A and MCP, as we talked about before. And this kind of connected system is going to allow us to automatically generate those interfaces, or in other words, we're going to get the benefit of the TM Forum interfaces flowing through to an agent without us writing a single line of code. Now that we have a sense of the upper ontology, how it connects to our telecom model, and how that model harmonizes the discrete standards and collectively makes them easy to both model and reason about, and then highly efficient to process, let's see what we can do with the ontology when we put it over the data we find in Snowflake. So here we see the aggregated inventory in Snowflake. The data in Snowflake is SQL, so it's effectively flat. They don't have the graph capabilities that EnterpriseWeb's ontology has, but there's enough information here that we can infer types out of what's provided. You can see here that the objects are at the level of things like routers, ports, containers, and so on, and pods, the kinds of things you would expect to find in a network inventory. And then, of course, connected metrics. But what EnterpriseWeb is able to do is infer types out of this data add dimensions using our ontology, and even extract entities and do mapping. Let's go ahead and do that. Okay, now I'm back in the network manager from EnterpriseWeb. I'm playing the role of a NetOps engineer who wants to onboard a new data source. In this case, I want to connect to my Snowflake repository. All I have to do is specify the connection details, a token so that I can connect. And just like that, the system is able to identify the type of workload that we're going to be working with, so Snowflake warehouse. And once we confirm, almost instantly, the system has interrogated the data that was over in Snowflake. It didn't move them or anything like that. It was able to do entity mapping and extraction. And what we can see is actually a couple of things. It identified we're looking at inventories. So it made that ODA service inventory something that we could actually expose, again, through the interfaces that will be connected to the system. And if we wanted to go a little bit deeper here, we could actually see what it did to those SQL tables. It went in and it looked at the elements table, and it was able to actually figure out, without going into a lot of detail, that there was additional tables it could actually create or synthesize from that data. So it could take it and start to add those extra dimensions to it. So beyond the metrics and entities that we already had, it will build a services table for us, right? So it's able to observe that higher order abstraction, a functions table, and then even to push back in the graph relationships that it's able to find. And now that we've added that connection to EnterpriseWeb, we can see instantly that it's populated inventory. There's about 70 or so objects here. It's dynamically typed each one of the objects that it inferred from that data, including services, as we mentioned, weren't originally in Snowflake itself. And each one of these has a very rich model. If we click into any one of them, the system auto-filled properties and attached a set of interfaces to this object. If we pop into the MCP interface that it's going to expose, we can see ODA and Open API specific elements here, things like service characteristics, service specification, and so on, all per the TM forum specs. And since this is really exposing a service inventory that's more than just the TM forum, since we're going to be exposing it to an agent through an MCP interface, it's going to include additional things that an agent will need, like a human level description of the service itself. This, again, interfacing with the Cortex LLM and other capabilities provided by the EnterpriseWeb platform, and provide the agent with all the details it needs to reason over this service. You can see if you go further, it'll include things like the lifecycle history, even the fact that it sourced this element through Snowflake, giving you full provenance of all the kinds of elements that it's going to be attaching here, whether they're metrics or state or even configurations. It'll extend into describing each one of the additional functions. And really, as we talked about, it gives you a full story that's going to be needed for working through TM Forum assets, APIs, and empowering an agent really to do the things that you're going to see going forward in the demo. And we can also see the system attached a set of interfaces, including the REST interfaces that will be buried in that ODA implementation as sort of discrete objects so that you can work with them in a TM Forum kind of way or through an agent. And then in addition to doing this with sort of building a full case around every one of the objects that we find in Snowflake, we can also visualize them. So we can actually get a look at the connectivity that's represented in that Snowflake inventory. And we can slice and dice this however we might want. If we want to see something that's more than services, let's just say functions and pods, it's just that easy to update the view. Now returning to the Snowflake view, note that the interface is bidirectional. If we update here, we'll see the additional tables that were all inserted here, services, metrics, etc. We can drill in on the details if we want and see those services that we just saw a moment ago in the EnterpriseWeb inventory, including their types and additional information here. And then what's important to note here is that not only did we enrich this data and insert the service classification, but this is going to remain synchronized at every level going forward, not just including sort of between EnterpriseWeb and the telecom inventory, but it's even going to take into account changes that might happen down the line to the TM Forum interfaces. If they collect additional information, it will push them back into this inventory or expose it out the other side. So to give an idea of just how far that bidirectional nature of the integration goes between Snowflake and EnterpriseWeb, we're back in the EnterpriseWeb Service Manager module, which is used by telecom engineers to design, deploy, and manage network services. Now, since this module is service-facing, what we see here is actually a catalog of things at that higher level of abstraction, if you want, the elements and higher order functions and services that we were able to discover in the network inventory that was in Snowflake was actually projected out of the catalog that you see here. There are rich models of all of these objects, so things like a 5G core, in this case AetherStack they call it, has a full model inside EnterpriseWeb that's leveraging that ontology you saw earlier. You can see a lot of the familiar concepts, again, brought across from that network ontology. And this is what allows us to not only automate services when we manage them in Enterprise Web, but also allows us to discover them from things like the network elements in the Snowflake inventory. The other thing worth noting about this catalog is that the services that we see here, and we can see there's only one that's been modeled at the service level, so a secure 5G core with IMS, is something that we should be able to order through the ODA Service Inventory. It has that capability to not only reflect items that are already there, but it has that second API set, the 701, that allows us to actually initiate workflow functions. In this case, a deployment or an order of the 5G core. So you're going to see in a moment that our agent will actually be able to perform that function again through that MCP interface. And then finally, just to sort of complete the picture here, our inventory in the Service Manager reflects those services we discovered earlier. In this case, it's just at a slightly different level of abstraction here, where it's dealing with the services as a whole. And of course, if we wanted to, we could drill into the details of any one of them through this lens. Now let's switch gears to the LangGraph agent that we're going to use to manipulate this service inventory and even place orders. So now with all the data in Snowflake and the knowledge plane in Enterprise Web, both exposed through MCP, what we're going to be able to do is run our little LangGraph agent here and actually query and run commands against an ODA inventory. So let's log in here. You'll notice that up front, it's actually asking us to authenticate with Enterprise Web, so it's extending governance over that entire ODA inventory. You'll have things like, fine-grained security down to the element with what's exposed from the inventory. We can start querying the inventory itself. What services are there? We can go into a little bit more depth if we want on any one of them. Tell me more about the 5G core. And this goes a lot further than just query interface. This goes from taking what would be sort of chatbot capabilities and extending them out with orchestration capabilities so we can actually perform commands. Now let's go ahead and order a service. We'll see automatically it looks at that catalog we saw before. It sees there's one service that's available to order. We'll go ahead and create a new one, and we'll specify the cluster. And just like that, it's deployed a new service for us. So back in Enterprise Web, we can see that it's deployed and that it's healthy. We can go into details about it, including its life cycle history and telling us even where the order came from through MCP. We even have an observability framework that was set up that's both feeding back information to Enterprise Web and through that ODA interface is actually updating our agent. So let's just pop into our agent for a second here, and let's actually ask about our new service. Now let's simulate a bunch of traffic to artificially bring down the service and see what happens. You can see that a couple of things occurred. You can see the agent actually detected an event and is even, in this case, actually suggesting a remediation. Observability is configured, but no AIOps policies were turned on in the system. Would you like to do that to fix them? So it's done a lot of reasoning for us in basically a few split seconds here, using correlation between the Cortex LLM, the MCP interfaces that we're providing, and the other support services from Enterprise Web. We can see that this is, of course, the health is reflected in the observability dashboard. There's a problem. You can see that it's just a simple matter of allowing the agent to fix the problem or make a correction. And you can see instantly the service health is restored back here in the dashboards. And of course, within Enterprise Web, here we'll start to see the healing events and so on the system is actually carrying out. Thank you for your time. I hope that showed you the power of the combined Snowflake and Enterprise Web solution using TM Forum assets. Thank you.
That was great. Thanks, Bill. I hope you all enjoyed the demo. If anyone's interested to get a little bit more architectural view, I'm going to dive a little bit deeper now for those that are interested. So here we go. Enterprise web starts, as I mentioned earlier on, there's essentially a gateway, right? A secure gateway that the interactions are going to happen through. And that gateway can be characterized as a unified behavioral interface. And I'm going to circle back to that later. And that interface is essentially representing a gateway, proxy, registry. And through that, we're exposing a no-code agent studio through a GUI API for the declarative design, deployment, and management of LangGraph agents. So amongst many other things you can do in Enterprise Web, you can now actually design LangGraph agents no code. The process literally takes a minute or two through a wizard that guides you to create a well-formed and secure LangGraph agent and then generates it for you and will stand it up for you. So it will be truly an independent agent living outside Enterprise Web that we generate on your behalf. That agent connects back to Enterprise Web through an ATA gateway and MCP server exposed to the gateway. In this way, the agents can take benefit or leverage Enterprise Web for middleware as a service, context as a service, and governance as a service. The agents that we generate can be chatbots, they can be LangGraph worker orchestrators, and we can actually even generate a richer form, sort of a hybrid, an agent that actually supports both talking to the network as well as ordering services and monitoring events. And the agents themselves can, in this case, are connecting to their own instance or connecting independently to Cortex for their interactions with users. Those interactions are done through a natural language programming interface and CLI so that users can talk directly to the agents and the agents can then call enterprise web services. But since they're independent agents, they could also, of course, they could call net devices or other services, other Snowflake analytics, etc. So they're not constrained to just working with enterprise web, but certainly they are essentially achieve superpowers through working with enterprise web. So let's dive deeper into how enterprise web does this. So as we mentioned earlier, there is an upper ontology in enterprise web, and that upper ontology provides generic cross-domain concepts, types, and policies. So think of that as enterprise web knows what business units are, what people are, what permissions are, what locations are, facilities are. Generic concepts that apply across all verticals. We also understand have a rich model of system types. So we know what protocols, formats, and schemas are. We also know various types of interfaces to clouds. So we understand AWS native services, Azure native services, GCP native services, as well as Snowflake native services. So this generic layer allows us to introduce new capabilities to a domain very quickly without having to manually encode them. So in this case, things like model context protocol and agent-to-agent protocol, which are generic across all verticals and domains, really shouldn't live at the domain level. They live sort of above the domain level. They're general IT concepts that we want to be able to exploit widely. The domain ontology sort of is nested inside, right? The domain ontology leverages everything from the upper ontology. Essentially, it inherits reusable concepts, types, and policies from the upper ontology. You can think of this as primitives, building blocks, as well as services to the domain that never have to be coded. In that regard, Enterprise Web's upper ontology is like a domain-specific language for creating domain-specific languages, a DSL for DSLs. For non-technical people, that just means we make it easy to build a domain ontology. We make it easy for you to import your own information models, import your own concepts, and extend and manage them because we're giving you this rich no-code environment on which to build your ontologies. You're not, historically building ontologies is a manual, time-consuming, tedious, and error-prone process, and maintenance is not a lot of fun. There's nothing about ontologies that have automatic governance or security, etc. Enterprise Web is wrapping the ontology with all of those capabilities, so you don't have to worry about them or implement them on a case-by-case basis. So the domain ontology is where we have concepts like the ODA Service Inventory, as well as Open API models for like TMF 638 and TMF 701. And below the domain ontology is actually domain objects, or instances of typed objects that are modeled for the domain. So essentially, it's a sort of a layered or nested approach here. And all of that is on top of the AI data cloud in this context, from Snowflake, your warehouse, as well as Snowflake's LLM, Cortex, is connected to Enterprise Web, and the telco cloud itself. So your NAS, your net vendors, etc., can all be connected via this solution. So you can be managing day 0, day 1, and day 2 operations and beyond uh, using a common model with common domain semantics, metadata, and objects, so you can have seamless handoffs between teams and enable the kind of intent-based orchestration and autonomous networking that telcos are looking for. Let's go a little bit further architecturally for those who like to go there. You could almost, some of you will probably have already recognized, this sort of looks like an onion style architecture, which is just a style of architecture, sort of nesting. Now, historically, that kind of nesting is done through static ports and adapters. So there's still a lot of point-to-point integration in the common approach. Ours is actually done through layers of abstraction, right? The whole environment is declarative. The entire environment is no code. Even if you are modeling, let's say, a net vendor CLI or an XNF vendor CLI, we're going to declaratively model that as an object. We're going to digitally represent it in Enterprise Web, and this is how Enterprise Web essentially enables real-time operational digital twins. Right? We can create a metadata description of everything, so that you can discover things in a common way, you can compose things in a common way, you can deploy things in a common way, and manage them in a common way. And that's sort of really critical to having a unified network view, to have sort of extreme automation, and to enable AI and autonomy. Now, I mentioned at on the beginning of this slide that our interface was behavioral. Behavioral interfaces are a design pattern, actually, right, or a type of design pattern that really focuses on interactions and connections. And that's really critical, as opposed to being a static interface over static applications and static databases that are all tightly coupled. Enterprise Web is presenting a behavioral interface. Enterprise Web is event-driven, intent-based, and goal-oriented. So all requests or events that come through that interface are interpreted on demand based on their real-time interaction context, right? So everything is a dynamic workflow, a dynamic control flow through this behavioral interface. So this is what gets us to these sort of highly dynamic and contextual interactions that personalize user experiences, that optimize transactions, and synchronize operations. And we do that all with strong governance. So through the unified behavioral interface, it's all going through, again, the sort of role-based access control, attribute-based access control, strong security and identity management. Enterprise Web registers all customers and partners. All of their people are given permissions. All of their users have permissions, and any agents that those people create are also registered, and they can inherit no more permissions than the user that creates them. So security is built in by design into everything that Enterprise Web does. So I hope that's helpful. We wanted to give people a little bit more than we were able to even do at the show on TM Forum, because we had a sort of a very highly constrained time to do our presentation. But I thought people would appreciate a little bit more architectural representation of the solution. Of course, please feel free to reach out to us at any time. I'm sorry, I forgot to mention that the runtime engine is AI native, cloud native, serverless, horizontally architected. So it's all built for high performance, scalability, and resilience. As I was just about to say, feel free to reach us out to us at any time. Again, my thanks to the TM Forum. My thanks to my friend Sreedhar Rao at Snowflake. What we presented today was integrating a true semantic layer over Snowflake, sort of near real-time telco-grade contextual automation. Thank you for your time. We'd love to do a proof of concept with you. Feel free to reach out to me on LinkedIn or Dave at enterpriseweb.com. Thank you.